Change is coming. There's a light out from the sun. A new time, a new day, a new world is coming. And I can see the dawn has just begun. A new home, a new way is on the horizon. We're making the world a better place, one person at a time. Making the world a better place, one day at a time. In the stars right now. Change the world. Change the world.
I think it's incredibly important that General Motors has taken this step towards EVs. We're talking about one of the world's most iconic companies here that will cause other people to stand up and say it's time. We're going to follow their lead.
Change is blowing like the wind through the trees. The wheels are spinning and life is in motion. And I can see a light shine through the leaves. A new spark of new life is on the horizon. We're making the world a better place, one day at a time. In the stars right now, in the stars right now.
I'm thrilled to see our vehicle content optimization capability chosen as one of the 6 finalists for the 2022 Informs Edelman Award. GM is bringing a host of new technologies to market, from hands-free driving assistance for added convenience to battery electric propulsion to reduce greenhouse gas tailpipe emissions. Decisions on what content to include in each vehicle program cast a long shadow. They drive engineering, design, development, and validation activities, as well as purchasing agreements and tooling investments. These are complex billion-dollar decisions. I view VCO as a great example of the value of operations research and analytics within the automotive industry. Developed fully in-house, I believe VCO serves as a competitive advantage for General Motors.
When it comes to buying a new vehicle, customers are faced with many choices and a budget. When it comes to making a vehicle, product teams are faced with many decisions and a financial target. But what are the optimal combinations of features that will please customers and return a profit for GM? The Content Optimization Tool Study helps us find the answer. Used by the Features and Technology Optimization team in the planning process, COTS considers market dynamics, business case needs, and customer feedback to simulate a vehicle's reception in the market. By analyzing thousands of possible combinations, COTS identifies the range of the most efficient order combinations that will maximize both market share and profit. The generated insights help the team identify unnecessary costs and reduce order complexity. As a result, we can deliver excellent vehicles that delight our customers and generate more revenue for GM. That's the power of data and analytics at GM.
Hello, on behalf of General Motors, our team is excited to share an initiative that we call Vehicle Content Optimization. I'm John Owen, and I lead the Advanced Analytics Center of Expertise at General Motors. I want to start by thanking Informs and the Edelman Committee for selecting GM as one of the finalists for this year's Edelman Award. It is truly an honor. As an applied science that can yield significant competitive advantage, often the most successful applications of operations research and analytics are hidden from view, behind a curtain of trade secret intellectual property. Today, I'm thrilled to pull back the curtain on one of our success stories, Vehicle Content Optimization. Vehicle Content Optimization, or VCO, is a forward-looking, customer data-driven analytical tool. In today's GM vehicles, customers will find hundreds of features. features that cover a diverse set of content, from core systems such as engines and transmissions, to safety systems, comfort and convenience features, seating configurations, panoramic sunroofs, infotainment systems, and styling features such as wheel size and finish, and much, much more. Using VCO, we can optimize GM's vehicle contenting and pricing decisions by understanding what our customers value and the trade-offs they make in their new vehicle purchasing decisions. This capability is enabled by a novel combination of custom market research, specialized discrete choice models, and proprietary multi-objective nonlinear optimization algorithms. To date, VCO has been used on over 85 vehicle programs throughout the world. It's a standard part of our global vehicle development process, and it has enabled over $4.4 billion of incremental profit. It's important to understand, though, that these achievements required more than a step function in analytical capability, but a high degree of interconnected change management across a wide variety of GM functions. Product marketing, engineering, program management, product finance, pricing, portfolio planning, market research, and information technology all played key roles and must work collaboratively across organizational boundaries to achieve these results.
Here at GM, we pioneer the innovations that move and connect people to what matters. With a vision to achieve a world with zero crashes, zero emissions, and zero congestion. Vehicle content optimization is a great example of how we enable this vision through our innovations that put our customers at the center of everything we do. Our analytics researchers invented and implemented advanced mathematical methods that use custom market research to understand what's most important to our customers and how they make decisions. I love that the results align our future vehicle content with what matters most to our customers.
Vehicle content optimization allows us to sharpen our focus on what combination of features are valued most by customers. This tool enables us to make customer-focused decisions and eliminate unneeded complexity. Importantly, vehicle content optimization is driven by consumer insights and preferences. As a result, this data is powerful because it reflects on what customers currently desire and reduces reliance on historical sales data. Overall, VCO is a critical tool that helps our product teams make data-driven, customer-based contenting decisions that enhance customer satisfaction and, in turn, revenue and financial performance.
The key business challenge we were trying to address with vehicle content optimization was to ensure that our future vehicles under development had the right feature content and pricing. This is a complex business problem that requires balancing future customer needs, cost, price, and profitability. Decisions on content and features can swing the profitability of a vehicle by hundreds of millions of dollars a year and significantly impact the appeal of a vehicle to consumers. Defining vehicle feature content is a complicated and long multi-step process that includes deciding on the content and features that will be available in the vehicle, including new-to-market technologies, grouping those available features, sometimes up to 100 or more, into bundles or trim levels that meet varied buyer needs and wants, determining which features will be standard or optional on each trim, and then optimizing the pricing for each trim level and for optional content. Adding to the challenge is that this process must be forward-looking, with content decisions being made up to 4 years in advance of a vehicle launch, which is then followed by an in-market life cycle that is typically 6 years. Making the right choices this far in advance is critical, as the decisions drive downstream engineering, tooling investment, sourcing, and manufacturing. All in all, when you consider the large number of features involved, combined with long lead times and the need to meet customer needs, along with balancing price and cost, vehicle contenting is a very complex business problem. This was the problem that VCO was designed to tackle, and it required significant invention and innovation along the way. This is not a new challenge in the auto industry, as GM and other competitors have been contenting and pricing vehicles for over 100 years. But the process typically has not used advanced analytics in the past. Instead, it has relied heavily on subject matter expertise and judgment. It has also used historical sales to understand how well similar feature content sold in the past, which is of little value for determining the potential for new content and features. Competitive benchmarking was also an important input, but this risked duplicating the errors of other companies that use the same rearward-looking process. VCO at GM was developed to help transform this process from intuition and rearward-looking metrics to a fundamentally new consumer and data-driven approach. And it has proven to be very effective in accomplishing this mission.
As Andy mentioned, defining the right vehicle content and pricing strategy is a challenging business problem. It's also a challenging problem mathematically. Typically, each vehicle model has over 100 customer-facing features. Each feature usually has from 2 to 8 distinct levels, sometimes even more. The specification of unique vehicle configurations depends on how many features are included and specific choices of which features to offer on each trim. For example, what kind of engine to offer, what size and finish of wheels will be available. We can offer a sunroof on certain trims and not offer it on others. For each nameplate in our product portfolio, we must decide how many trim levels, and for each trim level, how many unique vehicle configurations to offer. Depending on the vehicle brand strategy, there are different trim structures that range from 3 trim levels for a car program to more than a dozen trim levels for a pickup truck. And we make these decisions understanding the broader marketplace context, including alternatives within our own portfolio, as well as those of other automotive companies. It all comes together by making a very large number of decisions that all interact to determine the appeal of the vehicle to customers. Ultimately, we communicate all of these decisions through a vehicle order guide. This guide shows all the trim levels for a vehicle, the standard content in each trim, and optional content that's available. VCO works by creating an optimal set of vehicle order guides that delivers the best product content to consumers while maximizing profitability. In the example shown here, each column represents a vehicle trim level, and each row represents a feature that may be available on the vehicle program. Each cell of the table is marked S if the feature is standard on the trim, A if the feature is available as an optional upgrade, or if the cell is blank, the feature is not available. The task of VCO is to build an optimal order guide, placing the S's, A's, and blanks in the best possible positions. Ultimately, it's a complicated task, not just because of the combinatorics involved, but because each decision leads to a different balance between sales volume, profit, and customer satisfaction.
Vehicle content optimization provides a shared compass for stakeholders from planning, product marketing, engineering, design, and manufacturing. Using consumer preferences as true north puts our customers at the center of these investment decisions. My first exposure to VCO was back in 2013 when I was the Executive Chief Engineer for crossover vehicles. After reviewing the impressive results of several pilot programs, we initiated an analysis of our next generation crossover vehicles. For 3 months, we worked closely with the team to analyze over 200 what-if scenarios on program packaging. The result was a packaging plan that reduced complexity by 50%, aligned with customer preferences, and increased profitability by $300 million over our baseline. We went to production with our best crossover lineup ever and never looked back.
To understand the business challenges and complexity in making the right contenting and pricing decisions, we must first understand the complex dynamics in the decision space. As a consumer, when we shop for our next vehicle, we often ask questions like, what features do I want? How much am I willing to spend? If I can't find the exact vehicle I like, do I consider another vehicle from the same manufacturer, switch to a competitor, or wait till next year? At the heart of these questions are consumers making trade-offs between value and price to achieve their maximum satisfaction. As a manufacturer, GM needs to decide what vehicle features to offer and how to price them. These decisions directly impact consumers' purchase decisions. GM's contenting and pricing decisions also influence the stocking decisions of dealers because they're the ones selling vehicles to customers. Here, it is essential to recognize that customer decisions are at the center of complex dynamics. Automakers, dealers, and customers have different objectives and make different trade-offs. Even within GM, different business functions have competing objectives too. As Andy mentioned, product teams traditionally rely on past performance and expert judgment. They look back at historical sales to see how well vehicles were sold in the past, then use their experience or judgment to make a call about their future vehicle plan. To use a vehicle analogy, it would be like using a rearview mirror. But past performance does not tell us about changing consumer preferences or their interest in new technologies that emerge so rapidly in today's world. Another approach was to imitate what competitors do. This is like using side view mirrors. Competitive benchmarking is an important business practice. But if we simply mimic what competitors do, it at best allows GM to be a fast follower, if not worse off. The key value proposition of vehicle content optimization is to keep the voice of the customer at the center of what we do. A forward-looking windshield view allows us to better understand the diversity of what consumers really want. Our approach leverages the voice of customer and comprehends complex dynamics and trade-offs in the decisions. And our goal is to achieve all wins among consumers, dealers, and GM. At the heart of understanding what customers really want is to model the dynamics of consumer choice. Whether or not customers will purchase a vehicle depends on what content is available at what price, and how they make trade-offs between them. Customer choice leads to demand, which translates into sales volume, which impacts GM's revenue, cost, and profit. The more vehicles we sell, the more revenue we get. That is the objective of product marketing. On the other hand, the more content we offer on a vehicle, the higher material and logistic costs we pay. That is the concern of the engineering and supply chain functions. It is through the innovation of VCO that we develop custom choice models to robustly quantify customers' preferences and develop multi-objective optimization techniques to optimize GM's contenting and pricing decisions. As a result, we can best satisfy our customers, drive our company's bottom line, as well as balance competing objectives across different business organizations. Before my colleagues take you through the technical innovations of VCO in more detail, I want to briefly share the history of VCO. Looking back, it was an incredible journey for an enterprise like GM, moving people from intuition and known processes to a fundamentally new consumer data-driven approach. Our path to vehicle content optimization began 14 years ago with the first-generation proof of concept that demonstrated theoretical improvement but lacked business buy-in. In Gen 2, we significantly improved the fidelity of the choice models and developed a guided analytics process to engage the product teams. With cross-functional leadership support, we achieved great success in 10 pilot studies. As a result, VCO was approved to be integrated into GM's global vehicle development process. A new implementation team was chartered to provide dedicated VCO analysis for product teams globally. And a special IT development team was assigned to develop a production tool for VCO. In 2017, VCO was further evolved and expanded to Gen 3. Instead of analyzing what-if scenarios, one scenario at a time, which was very time-consuming and produced only incremental improvements, we developed ultimate capability to optimize vehicle order guides directly. Today, after over a decade-long journey with sweat and tears, no kidding, VCO has achieved full business adoption and integrations.
GMIT is proud to have partnered with the Vehicle Content Optimization team to deploy this important and innovative modeling capability within General Motors. Working collaboratively, our IT team created and now maintains a user-friendly, fully productionized, web-based user interface for VCO. We also enabled a unique capability to conduct VCO-specific market research studies for GM. And we partnered with the team to develop an automated infrastructure pipeline. Now, with the single click of a button on the web portal, end users can submit these computationally intense model fitting and optimization jobs on GM's high-performance compute cluster.
So, what does our vehicle content optimization process look like? It consists of 4 main building blocks. First, we conduct market research to learn what consumers want and how they make trade-offs. Second, we use this market research data to fit a consumer choice model, typically consisting of 50,000 simulated consumers. Third, for a given set of planned product offerings, we simulate customer purchase decisions and predict GM's resulting sales volume and profit. And finally, we use an optimization procedure to generate prescriptive recommendations to inform GM's contenting strategy.
One of the challenges we have with conducting the market research is the sheer number of vehicle features that we want to ask customers about. To address this challenge, VCO combines several forms of market research. In addition to a traditional conjoint exercise, we include the results of a build-your-own configurator exercise, as well as other information. Each exercise provides a different lens on consumer behavior, and together they enable us to extract stronger, more accurate insights about consumer preferences. As the next step in our process, we fit a mixed logit model to the market research data. Our custom approach is based on a Bayesian Markov chain Monte Carlo procedure. However, we modify the fitting process in several ways to incorporate additional data sources and expert expectations about customer preferences. Our algorithm computes distinct preferences for each consumer in the study to reflect the wide diversity of consumer needs and desires. We sample many draws from the Bayesian posterior distribution, searching the space for preferences that are consistent with the survey responses and with microeconomic theory. This is a computationally intensive process, but important for ensuring the accuracy of the simulation results. We implemented the fitting procedure using custom multi-threaded C++ code. While it is common to average the draws together to reduce the computational burden, in our context, we have found this is a poor approximation, producing estimates far from the center of the posterior distribution.
With consumer preferences quantified, we can simulate consumer behavior under alternative scenarios. Given a proposed set of GM and competitor vehicles, we can observe who buys what in our simulation and tally up the total volume and profit to GM. However, we had to enhance the standard mixed logit discrete choice model in many ways to cope with the real-world challenges of the VCO application. One classic concern with multinomial logit models is the presence of the independence of irrelevant alternatives, or IIA. Mixed logit protects against this concern to a degree, but it is still an issue, especially for VCO, where making one extra feature available in the order guide can double the number of configurations in the choice set. So, we modified the structure of our simulator to significantly reduce sensitivity to the size of the choice set. Standard choice models estimate demand assuming all products are available. However, in many countries, consumers buy primarily from dealers with limited inventories. VCO includes a simulation of dealer lots to reflect the real availability constraints that customers face. We also adapted our mixed logit model to incorporate consumer budget constraints, non-compensatory choice behavior, and competitor response to improvements in GM products. To improve fidelity, we calibrate the VCO model using vehicle time on dealer lot information from historical sales, as well as price elasticity data. Finally, we embed the capability to simulate what-if scenarios inside an optimization loop. This enables us to develop prescriptive recommendations.
The optimizer generates candidate order guides. Each candidate is expanded into a portfolio of vehicle configurations and sent to the choice model, which evaluates the resulting sales volume and profit, allowing the optimizer to construct an efficient frontier. GM can then choose to maximize profit or volume or a combination of both. An order guide specifies which features are standard, optional, or unavailable in each trim. So with just 3 trims and 250 features, the solution space contains over 10 to the power 358 distinct order guides, which is more than the number of atoms in the universe. And some vehicle programs have 8 trims or more. The optimization problem is very difficult. Each evaluation of the objective function requires a complete simulation of the underlying choice model, which is very compute intensive. The solution space is far too large for exhaustive search. The multi-criteria objective function calculates both sales volume and overall profit. Both are highly nonlinear functions of the order guide, creating a very challenging multimodal landscape to search. Since each consumer prefers different features and has a different willingness to spend money, even a small change to the order guide can have a significant impact on volume and profit. For example, adding a sunroof as an optional feature on the low trim may appeal to some of the consumers in the model, thereby raising sales of the low trim. However, this might reduce sales of the mid trim as consumers divert to the low trim. The net effect could be more volume, but less total profit. The optimizer must also satisfy a large list of business constraints. For example, in a feasible order guide, the all-standard configuration in the mid-trim must be more expensive than the all-standard configuration in the low trim. Similarly, if a feature is available as an option in the low trim, it must be either standard or available in the mid-trim. Engineering and marketing can also impose restrictions. For example, they may specify that one feature requires or precludes another. Some constraints, such as the trim mix, can only be imposed after evaluating the computationally expensive simulation function, making them difficult to satisfy. We use a hybrid optimization algorithm that combines elements from both genetic algorithms and the cross-entropy method. We supplement this with custom heuristics designed specifically for optimizing order guides and satisfying their business constraints. These heuristics are essential to getting a good solution in a reasonable amount of time, such as 48 hours on our high-performance compute cluster. For example, a standard genetic algorithm mutation operator might flip the state of a particular cell in the order guide. Suppose it makes a new feature available in the low trim, which is not currently available in the mid trim. The trim ladder constraint makes this mutated order guide infeasible. Rather than waste time randomly generating huge numbers of infeasible order guides, we developed heuristics that modify infeasible order guides to make them comply with the constraints, while making as few other changes as possible. The simulator computes the sales volume and profitability of each proposed order guide. The optimizer builds an efficient frontier over these competing objectives. The points on the frontier are the best order guides the optimizer has constructed, the ones that produce the most volume, profit, or combination of both. The VCO team works iteratively with the vehicle program team to decide which parts of the recommendations to adopt. As the vehicle program team imposes additional constraints, the frontier shifts inward. This provides a metric the vehicle program team can use to quantify the sales volume and profit impact of each proposed change to the order guide.
Ultimately, it's the results that matter, and the results of an independent validation study speak for themselves. The order guide that emerged from the VCO process generated 23% higher sales volume and 33% higher profit per vehicle than the original order guide submitted by the vehicle team. Not only does the VCO order guide increase total profit, but the resulting set of vehicle configurations do a better job of covering the space of consumer preferences than the original. Amazingly, the VCO order guide achieved these improvements while also reducing manufacturing complexity by eliminating 99% of the build configuration.
So, what does the VCO tool look like in practice?
We're going to review illustrative results from running vehicle content optimization for an electric vehicle. The baseline order guide from product marketing generated $500 million in profit. We grouped the VCO recommendations into 5 key themes: convenience, mechanical, interior, exterior, and infotainment. As you can see, most content optimization opportunities are related to convenience, mechanical, and interior features. Adopting all content optimization opportunities could increase aggregate contribution margin by $100 million per year.
In this scenario, it looks like our biggest opportunity is convenience. Let's take a look at the convenience recommendations.
Let's review the recommendations for the trunk opening. The VCO tool color codes features as either red, yellow, or green. Green represents features you should consider making standard or available. Yellow represents features you may or may not consider making standard or available. For these features, you may review other research before making a final decision. Red represents features you should not offer on the vehicle. The baseline order guide offered a manual trunk standard and a power trunk available on all trims. However, based on the data, we recommend making hands-free power trunk available on trim 1 and standard on trims 2 and 3.
In addition, there's other data available to support these features.
Hands-free power trunk had high consideration and selection in the features and technology prioritization study. Also, our key competitor is offering an optional hands-free trunk opening.
Based on this modeling, we can then review the profit and share impact of offering these features.
The VCO tool allows us to simulate any possible combination of standard or available features and measure the profit and share impact. Here, I'm going to demonstrate the impact of making hands-free power trunk available on trim 1 and standard on trims 2 or 3. It looks like making hands-free power trunk available on trim 1 and standard on trims 2 and 3 would increase profit and share.
This data informs us that there's customer demand for this feature and we should offer it on the vehicle.
Vehicle content optimization was a breakthrough for GM, providing us with an analytical tool that uses consumer preferences as a foundation to help product teams make these important contenting decisions for our future vehicles. Our VCO capability combines sophisticated consumer market research with state-of-the-art simulation and optimization algorithms, allowing us to run what-if scenarios and optimize the contenting strategy for each new vehicle program. The result is a user-friendly, fully productionized system maintained by GMIT and executed on each new vehicle program by a dedicated team of analysts.
At General Motors, we've built a dedicated team of professionals whose mission is to apply vehicle content optimization, or VCO, to every new vehicle program that enters our vehicle development process. Our VCO team works with global market research, the vehicle program team, and the pricing team to develop a list of vehicle features and prices to test. When the market research is completed, we run the VCO software using a convenient graphical user interface created by our GM IT team that wraps around the algorithms described previously. The VCO optimizer produces an efficient frontier, which is ultimately a set of order guides that both maximize GM market share and profit while leveraging customer preferences. The VCO simulator also scores the share and profit of the baseline order guide so we can evaluate the impact of any recommended changes to the order guide. Many of our analyses combine VCO recommendations with subject matter expert opinion from product marketing to develop and score alternative what-if scenarios. Ultimately, the product team accepts some, not all, of the changes recommended by our VCO process. The finance team assigns credit to VCO only for the content recommendations that are implemented by our vehicle program teams. As you might expect, where there is change, there were several organizational challenges that had to be overcome in adopting VCO. Several steps were taken to ensure our organization understood and embraced VCO. Best practices were developed and are still in place today. Examples include use of a standardized template for each VCO study to add structure to data collection, reduce the time to plan each study, and improve efficiency for key stakeholders who provide inputs. Creation of a database of VCO output from all studies to identify learnings that are consistent across multiple programs. Confirmation of VCO recommendations with other market research to make insights holistic and add credibility to our analysis. Presentation of results are also shared at key decision-making forums to obtain leadership buy-in for changing content. And lastly, a robust financial validation process is in place to provide a means to quantify the value VCO adds to programs' business cases. We have also applied VCO to the perennial question of complexity reduction. Minimizing complexity can reduce manufacturing and engineering costs and also helps ensure dealers maintain vehicle inventory with profitable and desirable configurations. Increasingly, program teams use VCO to identify configurations that can be eliminated to reduce complexity. Our VCO analysis helps ensure chosen configurations are the ones that maximize aggregate profit for GM. In 2014, VCO was officially integrated into GM's global vehicle development process. Since its integration, it has enabled cross-functional alignment of competing objectives, providing a common lens across program management, product marketing, engineering, sales, and finance. The fundamental tools and algorithms invented for vehicle content optimization have been useful in addressing many other challenges facing GM. In addition to complexity reduction, we have applied this innovative approach to many other portfolio planning analyses.
As a standard part of our vehicle development process, we work with each cross-functional program team to quantify the impact of changes made based on VCO insights. Each program execution team begins with a business case based on an initial set of vehicle content decisions. As the team moves through the VCO process, they choose which aspects of the VCO contenting recommendations to adopt, including the financial impact of these recommendations. The result is a revised business plan optimizing the financial return of the product program by creating more profitability, without impacting those features and content that delight and excite our customers. In total, VCO has contributed over $4 billion of variable profit to GM's bottom line since 2018. And that's not counting reductions in engineering design and tooling costs from the associated complexity reduction. So this process is vital to not only deliver great products for our customers, but also assuring they have the right financial returns for our business.
The innovations underlying VCO are regarded as trade secret by GM, providing the company with a competitive advantage in quantitative consumer choice analysis. As Kelly mentioned, since the creation of VCO, many of the core underlying techniques and technologies have been applied for other strategic decisions within GM. From future industry forecasting of electric vehicle adoption to quantifying consumer interest in new digital services. Vehicle content optimization at General Motors has enabled a true transformation in a core business process for defining future vehicle programs, moving from intuition, subject matter expertise, and rearward-looking metrics into a forward-looking, customer data-centric approach, driving impressive results for GM and our customers. Thank you for inviting us to tell you our story, for your attention and your consideration.